Okay, so this is number 30 out of your textbook in page 618, I believe. Now, they want the equation of this parabola in polar form. So we know that there are 4 equations to choose from. So which of the 4 is it? A quick reminder, recall that if your parabola opens either up or down, it's going to be one of the signs. If your parabola opens either left or right, it's going to be one of the cosines. So that narrows it down halfway. Now, do I use the positive or do I use the negative? Well, again, recall that for this whole section, you're going to have a focus at the origin. And that's the focus. And we know that this is the vertex with these coordinates. And that implies that the directrix is somewhere above it, like right there. And note that your directrix is positive because it's above the x-axis. So for that reason, we use the equation that has a positive. If this directrix had been below the x-axis, the directrix would have been negative, and we would have used this one here, okay? So we know it's this equation. Another FYI, note that we are playing with a parabola, right? We have a parabola, which means that the eccentricity is automatically 1. So I can take 1 for the eccentricity and plug it in there and there. The only thing left to discover is the value of k, and that is where this point comes into play. Remember that this is not x and y. This is not x and y. This is r and theta. And so take r and theta and plug them in respectively for r and theta. We get this here. Now let's take this upstairs. We get this there. Where did this 1 come from? Here, sine of pi over 2 is 1, and then 1 times 1 is 1. And so we get here that k is 2. And we also knew that the eccentricity was 1, because the eccentricity for all parabolas is 1. So, final answer. Here we are, and you can always check your answer by typing this into Desmos, and what will you see? You will see this graph right here.